Good evening. I am Brendan Wischweh. I am your child's physics teacher, and I will be taking them through the wonderful world of physics throughout the year. In this video, I'm going to give you a little bit about me and a little bit about this course and what it's going to be like for your child. First, a little bit about me. There's a slideshow that I'm going to be showing here that's also linked on my website as well. You can follow along either way. First, a little bit about me. I like to get outdoors and be active. I really enjoy bicycling. This is my wife and I. And 1,000 other people bicycling through the streets of Chicago. Once a month, there's a thing called critical mass where everybody gets together and makes critical mass where kind of take over the road with bicycles. Very interesting and very fun. This is me bicycle packing through Yellowstone. I did that for about 3 weeks there. And this is me as a young man bicycling through Italy when I was in college. Really enjoy traveling. This is my mother and I. On a glacier in New Zealand, hiking along, and the X is just for show. This is my wife and I backpacking through Iceland, yes it is, and this is my wife and I canoeing in the northern woods there. I enjoy lots of different things, including dancing, swing dancing there, learning a whole bunch of random new things, including working on cars. It's me taking out the engine of my truck. Playing Ultimate, including in the snow. Snow Ultimate is amazing. My new addition to the family here, this is my I only have one little daughter, her at 1 month there, and her now currently at 4 months there. Don't let these cherry-picked pictures deceive you. She's a handful. A little bit about my educational background. I went to Naperville Central High School, Go Redhawks. I went to COD then afterwards for 2 years, and that's a very, very good thing, and I highly recommend that for most people, as you can save tons of money. After that, I transferred over to North Central College for the remaining 2 years. I majored in physics and chemistry and minored in math. And side note, I really hated chemistry when I was in high school, but I ended up majoring in that. That's an interesting story, so don't be dismayed if your son or daughter doesn't like some subject that you think they actually do. Afterwards, I started substitute teaching and found out that I really do want to become a teacher, and so I went to grad school and got my master's in secondary education. To become a teacher, you need to student teach, and they said, you can do that anywhere in the world. And I said, sign me up. We'll go to Australia. So I went down to Melbourne, Australia, and my wife grew up half in Sydney, Australia, right around here. And when I was there, I taught a couple different classes. These are grade 9 and 10, so freshmen and sophomores in high school taking general science. As in Australia, they follow the British system of education where when students are going into their junior year, they have to declare whether they're going to college or a trade school route. And if they're going to college, they get to choose their major. So these are juniors in high school who have declared physics as their major, and this is me teaching them with a Captain America shirt that they gave me. And these are a bunch of other teachers that I taught with. Can you imagine your son or daughter having to choose their major before they got to school this year? Very interesting. A little bit about this course now. This is how you say it, Mr. Wischweh. And here's my schedule throughout the year. Now, a special note is I started the school year just doing part-time. I'm recovering from severe illness, and I'm making progress, and I'm hoping to transition back to full-time very soon here. So I'm teaching just 7th and 8th period right now, and I'll be transitioning back and taking on a larger and larger course load, and I'll be letting your son or daughter know when that happens, so if they need to see me and find me throughout the day, they know when I'm actually here. But once I'm fully here, this will be my full schedule, and as you can see, I'm basically just in this room, so very easy to find, except very early in the morning, I'm in room 273, which is just down the hall teaching chemistry there. All right. Physics here. We are teaching physics a little bit differently than when I was in high school, and most likely when you were in high school as well. When I was in high school, physics was really interesting, but it was a lot of, here's a complex problem, we're gonna figure out what equations go with that problem and solve that problem, end of physics. We're doing a slightly different approach here, which is very heavily laboratory-based. And so oftentimes what we're doing is before we learn anything, we will do a lab and measure something about the world. And from those measurements, we're going to have a class discussion and figure out, can we analyze this data in such a way that we can actually figure out how the world works and we can figure out the laws and equations that we actually use throughout the year just from our data, and we can, and that's what we do. And we find that to be actually very more effective. It's not something that I made up or anything like that, but researchers from starting at Arizona State University developed this back in the late 80s, early 90s, and have been developing it ever since. And the studies on students' retention of knowledge and understanding of the actual world and how it works are much higher using this approach than my traditional approach when I was in high school. So that's what we're doing here, and it works really well. I've been using it for many years now. So students are collecting data, and it's really a classroom discussion on both our data and how do we get to solutions. It's much less picking out equations as I described, and it's much more about students actually presenting and us discovering what are the actual truths through our investigation and analysis of our data. As you can see, we have a couple graphs over here. These are graphs that students have made from their labs, and we are in the process right now of figuring out what this stuff means and getting equations from these graphs here as well, which is actually really, really exciting. This is some of the research that's done on it. It's really focusing on critical thinking skills, which is critical thinking and problem solving. It doesn't matter where you go into or what types of fields you decide to go into, or your son or daughter does. Critical thinking and problem solving are always there throughout everybody's walks of life. And that's what this really, really focuses on, and that's what it really hones and builds up. And that's part of the reason why it is so much better, because we're not just focusing on innate physics knowledge that, to be honest, most people who come through this classroom aren't going to go on to study physics or other hardcore sciences where they really need to do this nitty-gritty stuff on a daily basis. However, coming across something that's brand new to them, like physics in this case, and knowing different ways and techniques of how do you actually figure things out is incredibly useful. And that's what we're doing. We're just doing it in the physics context here. It does go slower paced than a traditional physics class would, but the retention of knowledge is so much greater that it really does make sense. And it's heavily dependent on student participation, so students being in class is incredibly important, and not just in class, but really awake as well. It's expected that everybody does each homework assignment twice. And the reason for that is each problem that we write are written very specifically to find out new things and discover new things. I don't give many problems, but the problems that I give lots of time to work that out both in class and at home, and then for us as a class to discover how this stuff actually works and get to the correct solutions. So I will assign, typically I will assign like 8 problems at once, and students will go home and try those out first on their own to see where they're at, see how far they can get, and maybe that's all the way, but maybe that's only part of the way. And then when they come back to class, then each lab group of 4, will be presenting one of those problems to the rest of the class. And whether they got to the full solution or not, they're going to present what they have to the rest of the class, and then us as a class, we're going to figure out how do we actually get to the actual answer, and the correct answer for that matter, and also many times, what's another way that we could actually solve that same problem, so different methods of problem solving. We're going to do that for every single problem before we move on, and we take as many questions as we need to from students to make sure that everybody really understands this stuff. So it's a lot less busy work of less large volumes of problems and a smaller set of problems, but each problem is very, very important. And so after we have this large discussion, which usually takes more than one day, students are expected to go home and then, the ones that we've already done in class, I took notes on it, and I should know or have some idea of how to solve that since I did see it in class and I didn't ask any more questions. Now, can I do that on my own? And can I do it on my own without looking back at my notes as well? Did I really concrete it into my head yet, or maybe I'm still in that process? So doing that twice is essential for this reason. And then there's a quiz immediately after each of these problem sets that we do, and usually after each of the labs that we do as well. The quizzes are nothing long or strenuous, but instead they're 1 or 2 problems. It's usually a half sheet, just one side. Were you present? Were you taking notes? Do you understand the core concepts going on here? Not the necessarily nitty-gritty little tricks and details of each unit. These quizzes are meant to keep you on track here so that you can be studying effectively for the test and making sure that you're really understanding things as you go along here. Quizzes are generally open note, which the students don't know yet. There's only 2 exceptions, and those are kind of basic quizzes there where it's just kind of a little bit more factual recall, which we try to stay away from, and so the notes they would just be copying from the notes if they did that. And I'll let them know which ones those are before they do that. And then the tests are usually multiple choice and free response with a lab portion of the test, which is done within their lab groups. So the same lab groups that they did their data collection for that unit as well. So it's usually about 2/3 of the points is from a free response, about 1/3 of the points from the multiple choice there. There's some resources. First, I am hosting a website, which you probably got this video from. But if you don't know how to get there, if you go to the WVHS home page and click on faculty and staff, which is in the top left corner there, you'll see a list of everybody who works here. And there's everybody's name is hyperlinked to the resource that they're using, and they're giving content out to everybody. So in my case, it's linked to my website, so if you just click on that, you'll get right to my website. And 2 main things that are on there. One, the Google Drive is a online file bank where I can give all of the handouts that I give in class. They're all electronically available as well. And not just, it goes beyond just the handouts as well. I have additional review problems and other practice problems on there as well that I don't print out, but can be useful, especially if you're struggling in that unit. There's also a big resource list there as well, and I encourage everybody to look at that and try some of those out. The first one on that list is the physicsclassroom.com, and that is basically an online textbook for this course. Especially in first semester, the book that we have is a really good book, but we don't really follow it too well in the first semester here. However, the Physics Classroom, that first resource, does follow what we do very well. We do have a book, and I'll be passing it out to those who would like to take a book in the next few days here. And in second semester, we follow it a little bit more. If your son or daughter is struggling, we have some resources at Wabansie Valley High School. First, Tribe Time, every Wednesday we have a 30-minute break where all the teachers are available and students can come and ask questions to teachers. They're welcome to do that. I'll be here in 262, and there's other physics teachers in both of the classrooms next to our room here as well. There is the ARC, which is staffed by a science teacher every lunch period throughout the day. And then I'm here in room 262, this room, right after school every day as well. If there are retakes, students can retake 1 test per semester, and they have to do a little project to be able to show me that they understand this stuff, and then that allows them to retake the test, and I'll explain that to them after we take this test here, and it's relevant. But when I go to put a retake in the gradebook, what does that look like? Well, I have the original assessment in my example right here, and I have the retake, as you can see right here in this example. And the retake I make out of 0 points, and then I add on any extra points that they earn back by doing the retake. So for example, in this example, there's a 12-point quiz here, and not everybody got 12 points here. This person right here scored 6 out of 12, but then they retook it, and they must have gotten a 12 out of 12, because now they have 6 plus 6, which is the total 12 there. If they don't take the retake, because maybe they didn't retake that particular test, nothing will go in there, and on your side it'll look up like a dash. If they did retake it but they didn't do any better, I'll be putting in a 0, meaning they earn back 0 extra points, just like this one in this example here. Here are the units that we're studying here. We're basically going through how do things move, and then a little bit of how do things move, and electricity and magnetism. How does that stuff work, and how does that influence motion as well? Yeah. All right. Well, that's it. Thank you for watching, and have a nice night.